Hey everyone, Kevin from mechanicalavantage.com. Gonna change gears in this video a little bit and talk about this jet ski lift. So this is a jet ski lift that I've had for quite a while, and during a storm, pretty bad storm, part of the lift got broken. And so if we look down here, you can see that outside bracket is gone, and what it should look like, that bracket down there. And so I have a couple of the brackets here that I took off the other part of the jet ski lift. And this is what I am looking to replace. So that would kind of go like that to capture around the post. And then each of the cross members comes in and captures into the bracket to be held. And this is an aluminum extrusion that the manufacturer used to make, and they don't make it anymore. So I can't, the easiest thing would be just to go go to some vendor and say I want 2 of these and be done with it. But they don't make it anymore, and so my options are either say the heck with this jet ski lift or figure out how to do it myself. And as I was going and finding they didn't make these anymore, I thought, what am I going to do? And then I remembered, hey, I've got Fusion 360 and I also know how to design things. So I'm going to make these brackets out of sheet metal parts, and I'm going to use a company down in Wilson, North Carolina called Barnes Metal Crafters. I've known Nick there for quite some time, and so I sent the idea for this over to him, a rough idea, and he threw me back a price pretty quick. And I think he's also going to show us the process of forming these up when I send them down to him. So with that being said, let's hop over into Fusion 360 and see how I can make a set of replacement brackets out of sheet metal instead of aluminum extrusion. I'm in Fusion 360 and I'm going to get ready to replicate some of the core components out in the jet ski lift so we can fabricate the brackets. The first thing I want to do is save my design, so I'm going to go ahead and hit save. And I've already created a project called Jet Ski Lift Bracket, and so I'm just going to give this design a name called Lift Brackets, and I will hit save. Now we're in an autosave sequence, and Fusion's going to autosave the work that we're doing, so if we crash or make a mistake, we can always go back. I want to make a component that's going to represent the upright tube, so I'm going to go ahead and right-click on Lift Bracket and say New Component. Now another way I could get here is to go to the Assemble menu and choose New Component, or use this New Component button right here. And the dialog boxes are now the same, no matter if you right-click on the design name or use it from the Assemble menu. I'm going to name this Upright Tube, and I want to activate it, and then I'll hit OK. I don't have any geometry drawn, but I know that this is going to be the core piece of my design, and I don't want this to move around at all. So even though I don't have any geometry, doesn't mean that I can't create a joint. I'm going to go to the Assemble menu, and I'm going to choose an as-built joint between the upright tube component and the origin. And you'll kind of see it shake there. And that's letting me know that when I start drawing, whatever it is that I draw, it won't be allowed to move. So I'll hit OK. And now I want to draw my rectangular tube. So I'm going to create a sketch on the top plane. And from the create menu, I'm going to use the center rectangle option. I'm going to start from the origin. And I know this is going to be 2 by 2, so I could hit tab 2. But instead, what I'm going to do is just dimension one of the sides and then set both sides to be equal. And that will turn it equal, and I'll have a square that's 2 inches by 2 inches. I'm not going to fillet anything or do anything like that. I'm just going to go ahead and finish my sketch. And I want to extrude this out. When I extrude this, I could go straight up with it, but I think in my case, it might be easier to go a symmetric direction with it, and you'll see why I might do that way as we go. So I'm going to choose symmetric. I want the whole distance, and let's just say this entire chunk is going to be 4 inches in length. And I'll hit OK. I know from measuring that the radiuses of this tubing is 1/4 inch, so I'm going to fillet those now. So I'm going to go ahead and grab the edges. Notice you can pick through the edges through the model if you can kind of get your mouse over the top of them. And I'm going to set that fillet radius to 1/4 inch and hit OK. And the last step I want to do with this tubing is turn it into tubing by using the shell command. I'm going to click on the top face and the bottom face, and I'm going to give it a thickness of 0.095 inches, and I'll hit OK. And there's my first component that I want to design. If I activate my top level design, I can click on this. I can't move it because it has been, an as-built joint has been created between the tube and the origin, so it can't move. I want to create another component, so I'm going to shut off this upright tube for now, and I'm going to say new component. So same thing again, I'm just going to call this a cross tube. Again, this is just going to be a standard component, and I'll hit OK. And I'm again going to sketch on the origin using the rectangle command again, center rectangle. I'm just going to snap to the origin and drag up and out. In this case, it's going to be 2 inches tall, but only 1 inch wide. And I'll finish that sketch. I don't really know what the radius is on this piece of tubing, and I don't really care. So I'm just gonna extrude this some distance. Let's go 3 inches should be enough in this case. And I'm gonna repeat the same process again. I'm gonna fillet the different edges here. And let's use a fillet radius of this one of 0.125. And I'll hit OK. And I'm gonna shell this again. Same thickness, 0.095 is my last piece of tubing, and there's my second piece of tubing there. Now I also know on this part that there's a couple of holes punched in here, so I'm going to go ahead and put a sketch on that face and sketch in a couple of points. I'm going to drop in a point, if it'll let me grab it, right there, and a point right there. I know that these points are an equal distance away from the center line of the part. And so I'm going to do something. I'm going to project in this part's x-axis. So I'm just going to come down here. I guess it's going to be the y-axis, and I'll do it as construction. So I'll click on the y-axis, and I'll hit OK. Now, why did I project in the axis line instead of just drawing a line from the origin? I like to use work geometry whenever I can because you can't delete, change, modify, flip, anything like that with work geometry. So it's a super stable geometry to work from. Now that I have that in there, I'm going to go ahead and use the symmetry constraint between this point and click on this line. And now you can see that they're lined up and they're an equal distance away from each other. So I'm going to dimension between these 2 points, and I measured this to be 1 inch. And I also know that between the edge and this point, it's going to be 0.75 inches. And I'll hit OK, and I'm going to finish the sketch. These are through holes that a bolt hole goes through. So rather than drawing the circle, I'm going to use the hole command. So we'll use hole, click on the point, and for the distance, I'm going to say I want to go all the way through. And now I could just set the clearance size for a 3/8 inch bolt, but I want Fusion to do the heavy lifting for me. So under the hole tap type, I'm going to say that I want a clearance hole, and I'm going to tell Fusion the type of fastener that goes through there. So I'm going to say ANSI unified screw. I'm going to say that this is a hex head bolt, and its nominal diameter is 3/8 of an inch. And when I do that, Fusion figures out what that size is, and I'll hit OK. And now I have my cross member component created. I'll turn my upright tube back on, and I guess I'll activate the top level design. And now let's assemble this part. So I'm just going to go and do a joint. I'm going to hover over this face. Now, as I try to get to the center point, you can see when I put my mouse over there, I can see it, but as soon as I try to get there, it goes away. If I hold Control down on Windows or Command down on Mac, it locks those selections in so I can get to it. So I'm going to go choose that option right there, that little center dot, and I want to put that at the center right there. And Fusion's going to put that into place with the rigid joint. However, I want a 1/4 inch gap. The way that this part is designed, the real life jet ski lift, there's about a 1/4 inch gap. So from this front face to the center of those holes is 1 inch. And I'll hit OK. And now I have that aluminum cross member put in place. I need another one over on this side. So I'm going to right click on this component name and say copy. Right click on my design and then say paste, and it's going to paste a second one in. And I've got some move options. So I'll just kind of move this guy and rotate it back 90 degrees. Wouldn't be necessary. It'll just make my life a little bit easier. And now that I've got that placed, I'll just do a joint, put my mouse on that face, hold the Control or Command button down, and then select that point and align it up with that point right there. And again, I'm going to offset this a 1/4 inch, so 0.25, and hit OK. So now I've got the structure of my design done for what I need to do. I've got my upright tube, my cross tube 1, and my cross tube 2. So this would match the geometry that's out on the jet ski lift. And I'm ready to go and make my brackets, almost. One thing, sometimes these joint symbols can get a little annoying to look at, so I'll just hit the eye here to shut those off for a minute. And I know that I want to make some sheet metal components, but I have to make sure that I have the right sheet metal rule in place. So I don't have that rule. I'm gonna go to the sheet metal and go to modify and sheet metal rules. And I'm gonna find a rule that I wanna start with. In this case, I'm gonna use the aluminum inch. I'm gonna right click on it and say new rule. And it's gonna start with a copy of the rule that I started from. So I could call this 1/8 inch aluminum, however you wanna name it. I know a popular way to do this is to use gauge thicknesses, things like that. So for my thickness, this is going to be 0.125. And the K factor, I talked with the company that's going to make this for me, and the K factor that they use for this is going to be 0.33. So I'm going to type in 0.33. And what the K factor is if I took a piece of metal and bent it, a piece of flat sheet metal, there's a plane somewhere between the outside face and the center line, where when you bend the material, that plane neither compresses nor stretches. It's the neutral line. So that's the ratio between those two is the K factor. This is what allows you to fold up sheet metal and get a very accurate result. And then I'm gonna look at the bend conditions and make sure that my bend radius is right. The tooling that they're gonna use to make this is gonna be 1/8 of an inch. That's set to thickness. Our thickness is 1/8 of an inch. So in this case, my rule is now good to go for what I wanna do. So I'm gonna save that rule. Now you see in my list of sheet metal rules, I've got 1/8 inch aluminum. So I'm gonna go ahead and close this. Now what I wanna do is make my outer bracket. So I'll right click and say new component. And this time Fusion's picked up that I want a sheet metal component because I'm on the sheet metal tab. And otherwise I would just hit the drop down and choose what I want. And I'm gonna go say that I wanna use that 1/8 inch aluminum rule for this. And I'm gonna rename this component to be outer bracket. And hit OK. And now you can see that all my parts ghost out and I'm working in the outer bracket. To design this bracket, I'm going to use a modeling technique called top-down modeling, where I'm going to use the geometry that's existing on the screen to design the geometry around my part. So I want to create a sketch and I'm going to put it on this top plane up here. And I want to project in some of the edges that I'm going to need to work with. I want to do that as construction, and then I'm going to hit P for project. And I'm going to click on this edge, this edge, this edge, and that edge. I also want to project in that outside edge there and that outside edge right there. And then I'm going to go ahead and hit OK. And now I have those edges of my design projected. If I were to shut off some of these, you'll see that we're just projecting in the edges of those members, because I want to use that to design my piece of sheet metal. Now in some of the places I'm going to be exactly on the faces, and then I'm going to put a little bit of a gap in here. So when I draw my sheet metal profile, I'm going to turn my construction off, and then I'm just going to come down here and draw like this and come up and come over. I'm not being super careful right now, and I'll come down and come across. So there is going to be my sheet metal design. I know that this leg and this leg are going to be equal at some point. And I can also add some other constraints. I'm going to use a collinear constraint between here and this line, and between here and this projected line. So that sets me up that way. I'm also going to do it for here and here, and for here and here. Now for the legs that are just kind of hanging out in space, I want to leave a little bit of a gap in case everything doesn't line up exactly. I can, as long as I can get a bolt through it, I can tighten everything down and get it to squish in. So I'm going to do a dimension between this edge and this edge, and I'm going to set that gap to be 0.0625 or 1/16 of an inch. And then I'm going to set the same gap over here. Instead of typing that in, I'm going to reference in this first dimension. And probably what would have been a smarter thing for me to do would have been to create a design parameter called gap that I could have referred both of these dimensions to and changed it from the modify change parameters menu. But this is a pretty simple design, so this will work. I'm almost all black and fully constrained, but the only thing I want to do that's left is I'll just come and I'll set this dimension to be, let's go 1.5 inches for this length. And so now everything turns black and is fully defined. And now it's time to turn this into a sheet metal component. So I'm going to finish my sketch, and then I'm going to use the flange command and click on this edge. Now I'm not going to see anything happen until I give it a thickness. And when I give it a thickness, now I'll see that it starts to show my sheet metal thickness. And with this, I want to make sure that my design stays on the outside of the line. I also have the ability to go on the inside or to split the line using symmetric. But I want to go to side 1 so that my design is on the outside of the tubes that I'm working with. I'm also going to do this symmetrically. So right now you see it's going one direction. So I'm going to say symmetric, and things work a little bit differently in sheet metal currently. Instead of entering the half or the whole width, the only option that you have is the whole width. So I'm going to say 1 inch, which is going to give me a 2-inch overall height. So I have that good to go, and I'll say okay. And there is my sheet metal outer bracket, the main part of it. I have some holes that I need to punch on through here. So let's go ahead and make those. So I'm gonna put a sketch on this face, and then I already have the hole locations. So instead of redoing those, I'm gonna turn on my construction and I'm gonna do P for project. And then I can project in that edge and that edge of the circle, and I'll go ahead and choose okay. Now that I have that done, I could even shut off my cross tubes. I don't need to see those anymore. And even my upright tube if I wanted to, because now I'm just going to draw in a slot shape. So I'm going to turn my construction back off, and now I want to do a slot, a center point slot. I'm going to lock it to that origin spot and drag it out a little bit, and then drag this up. Now, I don't know exactly how tall I want to make this. I want to make this as tall as the circle is, so I can just use the coincident constraint in this case to go from here to the circle. I guess I'll have to use tangent on this one, from this line to the circle, and then so that's set that, and then I can set my total overall distance. I want to dimension the outside to outside of this, so I'm going to right click and say pick circle arctangent, and I can click on that quadrant and come up here, and let's call this maybe 0.5 inches. That's probably enough. I just want to get a little bit of slop in here in case the hole isn't perfect or the bends aren't perfect, so I can get that lined up. And I can either pattern this down as a solid, or I'm just going to draw this over again. Oftentimes I like to do a pattern or a mirror, but in this case I'll just draw it one more time. So we'll do a slot, center point slot, and I'm just going to drag this out and up. And now I don't really even have to dimension anything. I'm going to use constraints for all the rest of this. So I'll just say equal between here, and then I'm going to say equal between this edge, and that should make these both the exact same size. I'll finish my sketch, and then I can extrude that region and that region. I'm going to choose the direction I want it to go, and for the distance, I know I always want these to go all the way through, so I'll hit OK. And now I need to get those same holes over on that side of those slots, so I'll turn on that upright tube and put a sketch on that face. P for project as construction, just like we did before. Click on the 2 holes, and I missed the second one. Click on that edge and hit OK. And now I can shut off that tube, and we'll just go ahead and sketch it one more time. So slot, center to center slot. If I would have paid attention to the dimension, I want to make sure I'm not construction. I could have just referenced that last, and I did the wrong one there. I could have just referenced that last dimension that I used. So I'm going to come back to slot, center point slot, click on the center, drag out, drag that up, and I'll say tangent between that and that. And then from the quadrant to the quadrant, again, is going to be 0.5 inches. One last slot to go. Center point slot, from that point, come out, come up, and on this one we can just use the equal constraint between those 2 edges, and then from this arc and that arc, and that'll make my circles the same. I'll finish my sketch, and now I'm going to extrude out this region and this region, pull my arrow the way I want it to go. For my distance, I'm going to say all, hit OK. And the last thing I want to do on this bracket is add some fillets. So I'm just going to use the fillet command and click on that edge right there, and that edge right there. And for the fillet radius, I'm going to give this a 1/4 inch radius just to round it over decent, and I'll hit OK. Now if I turn on my other components, You'll see that that sheet metal bracket fits exactly around it. All the holes line up. I've got a little bit of slot factor there to make sure I can get my bolt through. So I'm pretty happy with that. If I'm not careful though, one thing I haven't done is I can click on this bracket and move it anywhere I want it to go. It's in place right where I want it to be. So rather than adding a joint, I'm gonna do an as-built joint because it's located right where I want it to be. So I'll choose as-built joint between the bracket, and I can pretty much choose any component I want. I'll use the upright tube in this case, and it's gonna be a rigid joint, and now I can't move that around anywhere. And I can activate my top oval design. And there we can see I've got my outside bracket ready to go. A little bit of a gap there. Sometimes in CAD things look a lot bigger than they are. That's only a 1/16 of an inch. So it's not really that big of a gap. And we can repeat the process to do the inner bracket. So I'm gonna right click and say new component. It's gonna be sheet metal. It's already chose the design that I have, the rule that I've got used in this design. And I'll call this inner. I don't want my caps lock on. Inner bracket. And I'll hit OK. And then we'll just repeat the process again. So I'm going to put a sketch up on this top plane. And I'm going to do P for project. And I need to project in some geometry. I'm going to project in this edge and this edge this time. And I want this outer edge and that outer edge. And I can hit OK. I'm going to turn my projection off, and then now it's just going to be the same thing. So I'm going to draw a line up, over, up, and over. I don't know how long this is. I could dimension it, but I know I want it to be as long as the other bracket. So I should have projected in a couple more things. I'm going to do P for project one more time. I'm going to click on that endpoint, and I'm going to click on that endpoint right there and hit OK. And now I know the length is going to be vertically located between that endpoint and horizontally located between those two endpoints. Now I've got that set. I'm gonna give this a collinear dimension, a collinear constraint I should say, between there and there. And we'll say that those two are collinear. And then now I'm just gonna go and dimension this. Again, if I would have made a master parameter, it would have been easier on myself, 0.0625 to get my gap dimension. And I'll dimension from there to there. And I'll set that equal to the first one. And now you see that my inner bracket is good to go. So I'm going to finish my sketch. And now I can use my flange command. Let's pull this up to make sure that fusion is on the right side of the design in this case. And you can see it is not. It's cutting into my tube. So I need side 2, so that looks good. And I'm going to say symmetric. And again, it's going to be 1 inch to be the same height. Now I could have extruded to the other face. Lots of different ways I could have made that bracket right there. So I'm going to go ahead and hit OK. I'm going to turn off these other components. And now what I can do is I can reference the other slots on the bracket. So I'm going to create a sketch on this face. And now I'm going to do P for project. And I'm just going to click on the different edges that I want to participate in this slot. So it really wouldn't matter which edges I'm using here. So there's one of the slots I want. And then here I'll just go grab those 4. And I'll hit OK and finish my sketch. Now I'm going to extrude that region and that region. Pull it through. The distance is going to be all. And hit OK. And there's that. And now let's go and put a sketch on this face. And again, we're going to do P for project. I'm going to click just the geometry that I want to project and hit OK there, and I'll do P for project one more time. I could have done them all in one shot, but I split it up into two, and I'll hit OK. Rotate around a little bit. I can finish my sketch and do my extrude and click on this face and this face, pull it through a distance of all, and I'll hit OK. And last thing I'm going to do is just do the fillet command. Click on wrong edge, so I'm just going to X that edge out, grab that edge, and that edge, and I want that top edge, and I'm just going to rotate around and grab this last edge and hit 0.25, and that's all filleted out. I'm going to turn on the visibility of my other components, and the last thing I'm going to do as far as design goes is to lock this thing in place. I'm going to revert it back. I'm going to do an as-built joint between that bracket and the tube right there, and I'll hit OK. And now everything in my design, let me grab the top, nothing will move. Everything is good to go. So that is designing the inside and outside brackets. You can see I've got roughly a total of 1/8 of an inch of gap on both sides when it's all said and done. That should be more than enough for this design that I need to do. When I put the bolts through and tighten this down, this is going to suck everything into place, so that will be good. If I wanted to look at my flat patterns, I can activate this part. I'm going to right click on it and say isolate so we just see it. Expand this out. And now I need to create a flat pattern. So I'm going to choose to create a flat pattern. I'm going to choose that face right there and hit OK. And Fusion's going to flatten that out for me. So that's what the bend lines would look like on this particular part. And I can finish up that flat. And now I'm going to activate the outer part and do the same thing. So it doesn't really matter which face we grab here per se. Sheet metal rule, I'm sorry. I'm going to click on the flat pattern and click on that face and hit OK. And there's the flat pattern of my other bracket. I'll finish my flat pattern and I can activate my top level design and turn the visibility of everything on. And now what I think I'm going to do is before I send these out to have these actually fabricated, I want to make sure that they fit. I've got a 3D printer. I'm going to print these two brackets on the 3D printer and see if when I take them out to the jet ski bracket that everything lines up, and I'm sorry, the jet ski lift, and when I take them out to the lift and put them on, will everything line up and will it all bolt together? So hopefully I'll be back with a little picture or video of that process. Okay, I got the 3D prints made and they're functional enough to test. You might be able to see I broke it a little bit trying to connect this bar up there. So basically I'm pretty happy with it. It looks like it's going to line up and the holes are in line enough that way when it comes together that I'm pretty dang confident that when I get the sheet metal pieces back that they're going to line up just fine. So it looks like this is going to work out pretty well for me. If you have any questions, leave them below in the comments. And as always, thanks for watching.